3D printing technology has led to the creation of a fascinating array of three-dimensional objects. The first 3D printer was invented in the early 1980s, and after decades of development, the technology has advanced rapidly. 3D printing, an affordable and sustainable housing solution. Part 1 of 2. Continue watching to find out what 3D printing technology can do.
Vegan, killer of injustice.
Karibu, beloved viewers, that's welcome in Swahili, one of the official languages spoken in Zanzibar. I'm Idris. The high-spirited people of Zanzibar thank the world's inventors for their high-tech innovations that help our planet become more sustainable. May you create many more great inventions through heaven's grace. Welcome to 3D printing, an affordable and sustainable housing solution, part 1 of 2 on Golden Age technology. 3D printing technology has led to the creation of a fascinating array of three-dimensional objects. The first 3D printer was invented in the early 1980s, and after decades of development, the technology has advanced rapidly, where today it can be used to print many more items than most people realize, from tiny objects to large buildings. With the world facing a housing shortage, 3D printing is not only speeding up the automation of construction, but also reducing costs. In our two-part series, we'll learn how companies are using this technology to build functional, affordable homes. According to statistics from the United Nations, about 1.6 billion people live in substandard housing and over 100 million are homeless. Countries all over the world are trying to find solutions for a massive shortage of homes with expanding populations. Today, companies are using 3D printing technology to revolutionize the construction industry, as they believe this new approach could make construction faster, cheaper, and more sustainable. One of these companies is California-based Mighty Buildings, which plans to start building 15 homes using prefabricated 3D printed panels at the end of this year, with the home set to be finished by 2022. Ruben, the co-founder and chief sustainability officer of Mighty Buildings, says, "With 3D printing, we are able to print exactly what we need. It's effectively zero-waste construction, meaning we are eliminating the 3 to 5 pounds per square foot that goes to landfills in a traditional build, which adds up to about 2 to 3 tons of carbon per unit." Mighty Buildings' method reduces labor hours by 90% per unit. Mr. Ruben thinks that 3D printing could also solve the current issue of labor shortages in home construction. This summer, the first ever affordable 3D printed home was built in Malawi, Africa. The successful debut of the home has brought hope for solving the severe lack of affordable homes that the country is experiencing.
This is Africa's first 3D printed affordable home. The walls took just 12 hours to build. Its carbon footprint is 70% smaller than traditional constructed housing. The house is in Lilongwe, Malawi. It was built by an organization called 14 Trees, which is the number of trees saved per home by not firing bricks. In August, it will start building the world's largest 3D printed affordable housing project in Kenya in partnership with building materials company Wholesome. 3D printed housing is starting to go up all over the world. It's being used to house homeless people in Austin, Texas, and to build an entire community in Mexico. This year saw the first 3D printed homes in the Netherlands and in India. Would you live in a 3D printed house?
14 Trees is also behind a 3D printed school project in Salima, central Malawi. Children in this area have started their education at the new 3D printed school, which was built in just 15 hours, using a computer-controlled nozzle that layered the concrete. The school can accommodate 50 students. According to UNICEF's estimate, Malawi is short of 36,000 primary school classrooms. "14 Trees Managing Director François Perrot says its success shows how 3D printing could be transformative in Africa, where there is a dire shortage of classroom space. Mr. Perrot estimates that by using 3D printing technology, Malawi could close this gap in 10 years, which otherwise will take 70 years using conventional methods. Wow, this is great news to Malawi's children and teachers and the country's educational system. A big thank you goes to 14 Trees and all the people who are involved in this project."
Vegan, because it's contradicting our loving nature to eat other beings.
Inspiring viewers, we'll pause for a moment now to thank heaven for all the physical comforts that we enjoy. Please stay tuned to Supreme Master Television. Welcome back to our program, 3D Printing Technology, Affordable Housing Solution, Part 1 of 2. Besides using 3D printing technology to make construction faster and cheaper, architects are finding ways to build 3D printed houses from eco-friendly recycled materials, which will certainly have a hugely positive impact on the environment. Earlier this year, Mario Cucinella Architects and 3D printing specialists of WASP, or World's Advanced Saving Project, collaborated to build the first eco-sustainable 3D printed house using clay. The house is named Tetra and is located in Massa Lombarda, Italy. With an area of about 60 square meters, it is comprised of a living zone with a kitchen, a night zone that includes services, and a circular skylight on its roof. The Italian architects have combined ancient building techniques with modern technologies to form recyclable, low-carbon, climate-adaptable housing. A crane was constructed using a multi-leveled modular 3D printer with 2 printing arms that have been synchronized as part of the construction. The clay is arranged in undulating layers that not only provide structural stability but also act as a thermal barrier. Tetra can be synthesized in 200 hours of printing while consuming an average of 6 kilowatts of energy and reducing typical construction waste almost entirely, says the construction team. Next, University of California professors and students have worked together to build a cabin and its interior from recycled material that would otherwise go into the landfill. Let's view this lovely cabin together.
The tiles on the front facade are made out of local materials, Chardonnay grape skins from Sonoma, California. And the tiles are designed to hold succulents and air plants which thrive in the Northern California environment.
Enclosing the rest of the house are 4,500 3D printed ceramic tiles that we call the seed stitch tiles. They have this woven texture that's very reminiscent of stitching, and you can see the bumps that make this kind of micro surface that looks really beautiful in the light, and they hang very simply from the building, so it's easy to install. It can go up really quickly. The furniture is 3D printed. Even the coffee table is 3D printed. And the coffee cups on the coffee table are also 3D printed out of recycled coffee grounds. And this is really one of the big points of this cabin, which is that a number of the materials are ecologically driven. They're found from sustainable sources, waste streams. The entire interior is clad with a bioplastic that's derived from corn. And it's translucent and it glows at night. This cabin is not just a research project, but because it's weatherproof and watertight, one can actually live in here and sleep in here. It's a really functional, usable space that demonstrates the potential of 3D printing in construction and architecture.
You know, there are many things in this building that are basically traditionally constructed, but then on top of that, we've layered totally new ideas and totally new technologies.
We're upcycling materials that would otherwise go into the landfill, but instead we're giving those materials value by turning them into building products. The implications of this cabin are really vast. There's implications that have to do with the housing crisis here in the Bay Area, for example.
3D printed houses made of recycled materials are not only an affordable housing solution, but also a great way to protect our environment. We hope that 3D printed buildings will soon be developed in many more areas of the world.
You can't be an environmentalist, you can't be an ocean steward without truly walking the walk. And you can't walk the walk in the world of the future, the world ahead of us, the world of our children not eating a plant-based diet. James Cameron, vegan.
On today's program, we'll continue by exploring 3D printed buildings around the world. In Western Asia, the United Arab Emirates has high expectations for the 3D printing construction industry.
Dubai wants to 3D print a quarter of every new building by 2025 to cut down on costly building waste that harms the environment. Cement is responsible for 8% of worldwide carbon emissions, and concrete accounts for 9% of all industrial water use. 3D printing creates 60% less waste than traditional construction because 3D printers use materials more efficiently, cutting costs by up to 70% and labor up to 80%.
Clearly, 3D printing is something that is going to impact construction massively in the future. The idea is to set a target for the country to slowly grow into the 3D printing technology. It will start at an incremental 2% growth on an annual basis until we reach our target of 25% and 30%. And the idea is to start with 3D printable parts that are actually being addressed in the market at the moment, whether it was door hinges or knobs or frames, until we gradually grow that into actual building material to reach the ultimate target.
The world's first 3D printed office building opened in Dubai in 2016. It took 17 days to print using a 37-meter-long printer and 2 days to assemble on site with a team of just 18 people. The building is home to the Dubai Future Foundation. The value of the global 3D printing market is expected to triple by 2025 to $300 billion. Today, just 2% of Dubai's buildings are 3D printed. Dubai is also exploring how 3D printing can transform medicine with 3D printed prosthetics, teeth, and hearing aids.
With all the great benefits of 3D printing technology, many countries around the world are using this method as an affordable housing solution. In Tabasco, Mexico, housing nonprofit New Story, together with construction technology company Icon and Mexican social housing organization HLA, has created the world's first 3D printed community as a means to combat homelessness. The homes are granted to local families currently living in extreme poverty and unsafe shelters.
Created for families currently living on less than $3 per day. Completed in about 24 hours of print time across several days. 500 square feet, 2 bedrooms, 1 bathroom. Curved wall and lattices for improved airflow. Ultra-reinforced foundation to last in seismic zones. Homes designed with feedback from families who will live in them. Icon's Vulcan 2 printer features tablet-based controls and an automated material delivery system. Lavacrete, a proprietary cement blend, is extruded layer by layer. 3D printed homes allow for safer, faster, and higher quality housing. This is no longer just an idea for these families in Mexico. The future of shelter is here.
It's wonderful to see the smiles on the faces of the children and families who will be living in these adorable 3D printed houses. Bravo to the companies, organizations, and individuals behind this meaningful project.
Vegan, because a simpler life would save our lives.
We'll pause for a moment now to take a quick stroll in the garden, and we'll be right back. Please stay tuned to Supreme Master Television. Welcome back to our program, 3D Printing, an affordable and sustainable housing solution, part 2 of 2. 3D printing is not only used for office buildings and houses. The world's first 3D printed steel bridge opened in Amsterdam, the Netherlands earlier this summer. The 12-meter-long, 4.9-ton bridge was installed over one of the oldest canals in the city. Relying on 4 robots fitted with welding torches, the bridge was built by layering 10,000 pounds of steel heated to 2,732 degrees Fahrenheit using an intricate layering process with a 3D printer. The bridge is fitted with cutting-edge sensors that measure in real time how it handles pedestrian traffic. The Dutch company MX3D is behind this ingenious and award-winning structure. Tim Hutchins, co-founder of MX3D, says, "If you want to have a really highly decorated bridge or a really aesthetic bridge, suddenly it becomes a good option to print it. Because it's not just about making things cheaper and more efficient. It's about giving architects and designers a new tool, a new very cool tool in which they can rethink the design of their architecture and their designs." Around the same time this year, a first-of-its-kind 3D concrete printed bridge named Striatus was introduced in Venice, Italy. This innovative structure was designed by the Block Research Group and Zaha Hadid Architects in collaboration with Incremental 3D and made possible by the Swiss building materials firm Holcim. The sculpturesque structure was exhibited at the Giardini della Marinaresa during the Venice Architecture Biennale exhibition. The 16 by 12 meter foot bridge was constructed from 53 hollow blocks, each printed from 500 layers of printed concrete. From its base, its curved stepped entry points placed at either end of the bridge lead up to a double curved deck. Philippi Bloch, a professor at ETH Zurich, head of the Institute of Technology in Architecture, and co-director of the Bloch Research Group, or BRG, says, this precise method of 3D concrete printing allows us to combine the principles of traditional vaulted construction with digital concrete fabrication to use material only where it is structurally necessary without producing waste. Thanks to this approach, the material was used only in places where it was structurally necessary, without surplus and thus significantly reducing the environmental impact. Unlike millions of buildings all over the world that are being constructed with reinforced concrete, generating large amounts of CO2 emissions, the structure is an unreinforced arched bridge, and its compression-only structure works like a traditional brick arch, being stable only thanks to its geometry. Because the construction does not need mortar, the blocks can be dismantled and the bridge reassembled again at a different location. If the construction is no longer needed, the sustainable concrete materials can simply be separated and recycled. Inspired by many new 3D printed structures, France also wants to build its first 3D printed bridge in Paris for the 2024 Olympic Games. The company awarded this project is X3E, a Paris-based large-scale additive manufacturing firm that specializes in concrete construction. The 40-meter-long footbridge, load-bearing structure or deck will be entirely 3D printed with concrete. The company aims to use 60% less concrete material in the building of the bridge compared to traditional construction projects. According to X3E, the bridge will validate the firm's 3D printing technology, paving the way for similar projects to be deployed throughout France and in other parts of the world. We look forward to learning more about the many innovative, new 3D printed projects that will change the way buildings are constructed, making them not only more affordable, but most importantly, sustainable and eco-friendly.
Vegan, victory for self-respect.
Attentive viewers, thank you for your company during today's program. Coming up next is Palomacy Pigeon and Dove Adoptions, a haven for rescued bird people, part 2 of 2, right after noteworthy news. May your life always be filled with positive energy through Allah's grace.
Our programs offer many languages. Please visit suprememastertv.com/schedule and suprememastertv.com/GAT.